So I did a little review, but now I'm going back to, do you remember when you had asymptotes that would run this way, and then you'd have a dot here and a dot here? Do you remember what function that was? Y equals 1 over x. Yep. And let's say that it's moved over 4 to the right and up 5. Then it isn't really 1 over x anymore. It's been moved. Would you please copy this sketch and then fix this equation to be right? It isn't 1 over x. It's 1 over x with a little of this added here and a little of that subtracted there. Now, why am I doing this? Well, there's graphing on your next test. And this is the hardest kind of graphing. You have been tested on it already. You did this. But now it's coming back with holes in it. That's the only difference. You've graphed all of these graphs before. It's just now there's holes in them. So this particular graph got moved 4 to the right, which would mean minus 4. And it got moved up 5. So that's a plus 5 on the outside. Are you with me so far? Now, this, we won't have a question that is identical to a test you were given like a month ago. So how would today's problem be different? It was on Friday's test. Well, there would have probably been something on the top and the bottom that would cancel. So let me show you how it would look different. 1 over x minus 4. Still got the plus 5 out here. But it might have had an x minus 1 and an x minus 1 in it. What does that create? It creates a hole at 1. How would I do that on this graph? Everybody, if you know how to put in a hole at 1, do it. If you don't know how to put in a hole at 1, you need to really pay attention. Somewhere on this graph, you need to put in a little empty spot. It's like a point that has an empty, hollow inside. So what did I teach you before? I taught you that a hole, you'd always start with this, and then you'd go, the hole is at 1 comma what? Well, you'd put the 1 in here, and you'd have 1 over 1 minus 4 plus 5. And that would be 1 over negative 3, so negative 1/3 plus 5. All I'm doing is simplifying this down. And that would be, it's like 5 minus 1/3, which would be 4 2/3. 4.67, I'm rounding here. So this is 4 2/3. I could put 4 2/3, that's legal. Or I could say like 4.66666, okay? And then on the graph, it would have been a lot easier to just be smart about it and go, well, I know 1 would be about here. And you go up and put an empty spot in your graph. So here's my green line. I'm going to continue my green line out. Gets closer and closer to the asymptote, never touches it. And then I'm going to go punch a hole in it at 1. See how it's just a little less than 5? Like maybe 4 2/3. Okay, so that's the only thing that's new besides, you've graphed all these before. Now I know, after a month, kids forget stuff, but you've graphed these before. You just gotta be able to graph them again, as I put a hole in them this time. All right, let's make sure you understand that we're just doing a little bit on graphing today. If I had said x squared minus 9, but there's an x plus 1 and an x plus 1, as soon as this cancels, do you get it's just y equals x squared minus 9? Except it's got a hole. Make a 10-second sketch of what that would look like. You know what that looks like. You graphed a parabola shifted down 9 before. Okay, parabola shifted down 9, so something like that. And then it's got a hole where? At -1. See, -1 is the thing that would make a hole. So I'm going to put a hole at -1. So I'm going to go over to where -1 would be. It's like right there. And I'm going to follow it down. And then right there is where I should put the hole. Boom. Parabola with a hole at -1. So did you notice that I put the hole in last? That's my advice. Graph like you used to graph. If you're ever stuck, make an XY chart. Because sometimes you're asked to graph something and you don't remember how to do it. Like, would you know how to do this? I wouldn't even know how to do that. So if I had to graph that, I'd go X, Y. I'd find a whole bunch of points. And then once I got enough points, I just had to play the connect the dots and I'd figure out what it looks like. All right, but what I want to teach you today is to be able to tell where the horizontal and the vertical asymptotes would be for this. I know where the horizontal asymptotes and the vertical asymptotes would be. And right now, you might remember how to do verticals, but you definitely don't know how to do horizontals. All right, so that's my goal for today. And horizontal asymptotes is one of the things that the night before the test, you're going to go look back at your notes you take right now because these are complicated. And you'll have to remember, how do you do the horizontals again? There's a little chart I'm going to make for you that helps you know how to figure out the horizontals on a graph. All right. So first, though, let's talk about the vertical asymptotes because when you do the domain, everybody write this problem down. X plus 3 over x plus 4. Tell me the domain. The domain gives you a little list of things x cannot be. And those things are either holes or vertical asymptotes. So I recommend you always start with the domain. Carlos, all reals except not equals x not equal to -4. Good. Okay. That x not equal to -4 is either a hole or it's an asymptote. Which is it? Asymptote. What kind of asymptote? Vertical asymptote. Everybody write VA and write down for yourself what is the vertical asymptote. Just said it. And then I would teach you how to figure out the horizontal asymptotes. The vertical asymptote on this thing is x equals -4. All right. Now, this one has an asymptote that's horizontal. And it is not 3, and it's not 4, and it's not -3, and it's not -4. So it's not one of those things you can just go, oh, there's the number. That's the asymptote. No, you have to do math to figure this out. So horizontal asymptote. Right now, you are not qualified to figure out the horizontal asymptote on this. We'll come back to this problem in a minute. We're going to make a little chart that you'll use, you'll have to memorize, to be able to figure out whether something's horizontal asymptotes. Sometimes they don't even exist. Sometimes it doesn't have horizontal asymptotes. All right. First, I have to get you across the idea that your function, make this little chart with me. We'll have horizontal asymptotes. And there's only 3 ways the function can be. The function can have we're going to make a third column here. for kind. Kind of function that it is. Here's an example of a kind of function. That's one kind of function. Here's another kind of function that is a different kind of function. And the third kind of function is like that. So let's talk about these three functions. What kind are they? I need to now make sure you remember what degree means. This function is degree 1 on the top and degree 1 on the bottom. Does that ring a bell? You remember what degree means? This function is degree 3 on the top and degree 2 on the bottom. This could have an x to the 0 on top, which kind of gives you the idea of how it's degree 0 on the top and degree 1 on the bottom. Every function is a fraction function. It's just that some of them are only divided by 1. For instance, up till now, you knew this was a function before, but then you didn't think of it as a fraction, but it's over 1, isn't it? So every function is really a fraction function. It's just that sometimes the degree is way bigger on the top, and sometimes the degree is bigger on the bottom, and sometimes they're the same on both. That's the three different kind of functions I have here. All right, that first kind, it's bigger, write this out, degree on the bottom. The one on the bottom is the big degree is on top. And do you get the middle one has the same degree on the top and the bottom? That's the only three ways it could be. It's either bigger on top, or it's bigger on the bottom, or it's the same on both. I'm going to put same degree on both. Now this next part, I like to simplify things. Like I make you dumb little rules, like if you can factor it, you should. That'll serve you very well all the way through high school. Whenever you're stuck on a math problem, look at it and go, can I factor it? Because if you can, you should. And then a lot of times that fixes the problem, okay? So this is the way I simplify it. The bigger degree on the bottom, I call it a bob. Is that a math term, do you think? No, it's just a way to remember bigger on bottom. Same degree on both, SOB. Again, if you write this on an AP calculus test as the reason that the horizontal asymptote is this way, do you think that the reader of the test knows what a SOB is? No, it's my makeup. I'm making this up. But it's a way to remember it. It's the same on both. And bigger on the top, that's a bot. And again, I'm just going to say, you're not allowed to write that on your test. That is not an official thing. There's no such thing as a bot. But it'll help you remember that for a bob, the rule is, the bigger on the bottom, that bob is an outsider. So its horizontal asymptote, by the way, the horizontals are always y equals things. The horizontal asymptote will be whatever's on the outside of the fraction. So is this one, oh, just a second. Bigger degree on bottom, Bob. Outsider, yes, double checking it. Yes, okay, good. Done it correctly. So, what is on the outside of this fraction? A 3. Y equals 3 is where the asymptote would be. Are you copying this then? Otherwise, you're dooming yourself that you cannot get an A on this next test. Just from not copying this down? Yeah, because you won't be able to answer the questions on horizontal asymptote, and then that's going to crash 2 or 3 of the questions, and that's going to mean you probably can't get an A anymore. You're going to get a B at the best. So, take good notes on this. All right, next one. Same on both. Those are so hard they'll make you sob. S-O-B, get it? I'm going to say that for last, because that's the hardest kind. Looking where the number on the outside is super easy. This next kind's also pretty easy. If it's a bot, there's no horizontal asymptote. Done. Those are very easy. If it's a bot, there's no asymptote. So I like to think of it as no bot. You know, kind of like robot. No bot. I'm going on record as saying, if I could wave a magic wand and make it so there weren't going to be any robots coming in the future, I would do it, because I'm kind of scared of what the future will hold with all these robots. There's going to be robots all over the place. They're coming, and they're coming fast. They're going to provide very cheap labor. That's going to replace people. I'm a little scared about that. But I can't magically stop there's going to be bots. So I might as well embrace it. They're coming. You're for sure going to be bots all over the place. So I actually am thinking of the bright sides of it, but there's definitely dark sides of it too. Anyways, no bots. Get the no bot. See how that goes together? All right. Then the only other one that you have to figure out is this middle kind. If they're the same degree on both, then let me talk you through what this really means. I'm going to go take this. You do not have to copy this. You just need to listen. X plus 3 over x plus 4. Remember, we're trying to figure out, would there be a horizontal asymptote if I graphed this thing? Would there be a dotted line that runs across it? And there is. And let me explain how you can figure out where that dotted line will be. That dotted line is what you're going to tend to go towards at the end. When the function's way over to the right, when you go way over this way, way to the right, your function will get closer and closer to that thing, but it'll never touch it. So if you put in a huge x number, like 1,000, if you went over 1,000 spots, the question would be, how far up do you go? So you can do that. You can put in 1,000, and then you can go, well, I'd be at 1,003 over 1,004. Would you agree that's pretty much 1,003 over 1,004 is extremely close to 1, isn't it? So then that's the asymptote. The asymptote's going to be at 1. When you put in 1,000 here and 1,000 here, that'll tell you, oh my gosh, I'm incredibly close to 1. All right, now there is a trick for this. And again, I like to teach you both how it gets there and give you a shortcut. And the shortcut for these, it's a lot faster than putting in 1,000 on the top and 1,000 on the bottom and then realizing what that simplifies to. The shortcut is just this. You make a ratio of the LCO. Ratio of the lead coefficients. What's the lead coefficient on the top? 1. What's the lead coefficient on the bottom? 1. What's the ratio of 1 to 1? 1. Y equals 1 is your asymptote then. All right, now if you could just have this chart with you, then the test would be easy. Well, you're going to say that, then you might as well say, if I could just use ChatGPT for the test, it would be easy. Yeah, it would. Just get somebody else to do it for you. That'd be the easiest thing of all. But you'll have to memorize this set of rules, okay? It's like when you go to med school, even though there's computers nowadays, they still make you memorize all the bones in the human body. Got to know every single one. Well, you'll have to memorize this chart. So it isn't that bad. It really isn't. It looks really complicated, but once you get used to it, here's the things, my little shortcuts that will help you. Bob is an outsider. No bots. I wish they could just outlaw bots, but it's not going to happen. Again, if we did, then other countries would just embrace the bots. They'd get incredibly cheap labor. They'd use them for their military, and then pretty soon we're like, oh crap, they've got huge advantages. We decided not to do bots. Anyway, so no bots, and then the last thing is, same on both. I don't have a snappy way to remember this, except they're the hardest ones, so they'll make you sob. The hardest ones have to do a ratio of the lead coefficients. So that's the first thing I'll identify is it bigger on bottom, bigger on top, or is it same on both? And then you'll have to remember what those little rules are, and then you'll be able to figure out the asymptote, and then you got to remember the asymptote, if it doesn't even has one, always starts with y equals. See how it always starts with y equals? All right, so here we go. I'm about to give you 3 functions. You figure out if they're bigger on the bottom, bigger on top, or same on both. Then you use that little chart I just gave you, except you got to memorize it for the test, and you figure out what the horizontal asymptote's going to be. So here we go. What's the horizontal asymptote? I'd be asking myself, is it a Bob, a Sob, or a bot? And then I would never write that on my test, because a bot is a nonsense word. It's just helping you remember the math, chart, and the rules. It's about degree, too. Remember, bigger degree on the top, bigger degree on the bottom, or bigger degree, or same degree on both. So, talk to the kid next to you about which kind is this, and so, what is the actual asymptote then? If it is a bot, or whatever it is, what does that mean for its asymptote? Talk to the kid next to you, please.
The same.
Okay. Did you realize it was same on both? And then what's the thing for sobs? They're the hardest ones. They make you sob. So then you got to remember this other rule, which is that it's a ratio of the lead coefficients. And so it's y equals, if you just wrote 2/5, you're wrong. Y equals 2/5 is the horizontal asymptote line. Okay. That makes sense to you. Let's do another one. Y equals x to the 7th was the horizontal asymptote. This will stump some kids, so don't be surprised when you talk to the kid next to you and they're like, I don't get it because it doesn't have a bottom. What's the horizontal asymptote? Talk to that kid next to you.
Because that's basically just x out to the 7th over 1. It's what's bigger on the top, so it's the outside number, and the outside number is 0.
All right, its denominator is a 1. It is bigger on the top. What's the rule for bots? No bots, none. There isn't any. All right. Next kind. Don't have to write this one down. All you have to do is tell me the asymptote for it. Be careful. So your brain should be going, okay, first it's all about the degree. And then I'm trying to figure out if it's bigger on the top or bigger on the bottom. The degree. Is the degree bigger on the top or the bottom? Which one is it? It's the same. Then I got to know, okay, what does that mean? If it's the same on both, that's the ratio kind. So ratio of what? Lead coefficients. Well, it's a 1 and a 1, so y equals 1. No, it's not. It's actually, Isaac?
1/5.
1/5, because that's the lead coefficient, since that's actually the lead term. There we go. Y equals 1/5. There would be a dotted line going across at 1/5. That's what that means. Okay. Now, let's put it all together into one problem. Everybody write this one down. This will be one main simple problem that's a lot like all your homework problems today. It's like the most important of the homework problems today. There's always, oh, let's not make it 3 and 3. Let's make it 3 and 8. And let's make this nope, I'm wrong. Just make it x plus 5. Don't need to confuse people here. Okay, can you tell me the domain of this? I hope by now you know how to do domains. Then can you tell me, is there a hole? If so, where? Is there a vertical asymptote? Remember, those things from the domain are either verticals or they're holes. And the last thing is the new thing I taught you today, where you run through those rules in your head of the degree. Is the degree bigger on the bottom, bigger on the top, or same on both? All right, this shouldn't take too long. So in the end, once you learn the rules of horizontals, it's not that bad. You just gotta learn the rules. The domain starts with a big R, a double bar R. Now I'm going to call on different people to give different answers, so finish as fast as you can. If you don't know, I will help you. All right. Tomas, it's you. Big R, except.
X does not equal -3.
Yep.
X does not equal -8. And X does not equal.
Wait.
No, X does not equal
-5. -5. Very good. It's very common for people to put 8 in there. We don't care about the top. You can make the top 0 all you want. Can't make the bottom 0. Okay, good. These two things, I'm not asking for whole right now. I'm asking these two things could either be this or that. Zola is absent today. Charlie, what could these two things be? There's only two things they could be. These guys. Or they could be? No. They could be vertical asymptotes or they could be a hole. All right, that's what those two things can be. And there is a hole. Row 4. Person 2, Bennett, that's you. Where is the hole then? Why can't I just put -3? Because it's a point, so -3 comma. Well, there's two kinds of kids. The kids who simplified this to x plus 8 over x plus 5. And those kids will do better on the test. I guarantee it. If the kid writes that down, they'll do better because two things. Number one, it tells them where to stick the negative 3. If you stick it back in the original problem, it won't work. So you got to write this simplified equation and put the negative 3 in, and what did you get? 5/2. You are correct. The other thing writing this simplified equation gives you is the ratio of the lead coefficient. In this case, we'll need that for the horizontal. The vertical, though, is just the other thing. This was the whole, so this must be the VA. X equals -5. And then the horizontal rules kick in, and I look at this, and I ask myself, is it bigger degree on the top or bigger degree on the bottom, or is it same on both? What is it? Same on both. And if it's the same on both, you use a ratio of the what? Lead coefficients, which are 1 and 1, and so this is y equals 1. How many of you had y equals 1 at the very end? Nice. I think you learned how to do horizontal asymptotes then. All right. Now the only thing that's not represented up here is would you have been able to graph it? And I just want to remind you that if you had to graph this, even I don't know how to graph x plus 8 over x plus 5. I don't know where it lives. I have no idea. But I could figure out its asymptotes. I just taught you that. The asymptote for this would be at x equals -5, so I'd know there'd be an asymptote running like that at -5. And I just figured out that the asymptote horizontally would be 1/1, which would be like this. Does that help me in making my graph? It helps a lot. What I'm going to be teaching you tomorrow and the next day, then, is how to get the rest of the graph. We know how to get the horizontal and verticals. And guess what it boils down to? The XY chart. Your best friend in graphing since week 1 in this class. Got to be able to make points. You'll be making a whole bunch of points. Stick in 1, see what you get. 9/6. So guess that would be it. 1,96, which does reduce, but you just graph a bunch of points. So if you can find the asymptotes and you can use an XY chart and make points, you'll be good. In the next 2 days, that's all we have to do in here. If you're good at making points, good at finding asymptotes, next 2 days you're golden. All right, let's do the homework. It is odds. So find the worksheet. Start with number 1. If you get the satisfaction by crossing off problems, you can cross off all the evens. 2, 4, 6, 8, 10 are gone, etc. Number 1. Jack Breen, would you please read me number 1?
F of x equals.
I know it's long, but just read fast.
3 in parentheses x minus 7 and then x plus 7.
Yep.
And then on the bottom is 2x and then in parentheses x minus 7.
Awesome. First thing I would do is cancel those. I would remember that I canceled them, so there's going to be a hole. And then I would write the simplified answer with y equals, because it's faster than f of x, 3 parentheses x plus 7. And on the bottom, I have 2x. There. I'll use that to figure out bigger on the bottom, bigger on the top, or same on both. And I'll use it to find the hole. They do ask for domain. They ask for it like last, but I would do it first. Because the domain tells me the things that could be the holes or the asymptotes. So let's start with domain. 5. Person 2. Car, that's you today. Can you tell me how do you do the domain?
X is 7.
Got to remember the big R thing. Comma. X cannot be what?
7.
And something else.
0.
Yes. Those are the 2 things. What can those 2 things be? They're either going to be holes or they're going to be vertical asymptotes. All right. We eventually are going to have to figure out the hole. So I'd rather do that first. The dice have chosen Luke Wilford. Hole's going to be at what, comma, what?
7, 3.
It does come out to 3. Very good. If you're like, how did he get that so fast? I don't know either, because it took me a while. But that's 14 times 3, which is a big number, divided by 14. Oh, wait a minute. 14 divided by 14 would cancel, and it's just 3. Maybe that's how he did it so fast. Is that how you noticed that? Ah, 14 cancels this 14. And I'm left with 3. Okay, cool. That's the whole. And then the vertical asymptote is the other thing. Remember, this is a whole, or this is an asymptote. And we figured out that one's a whole. So this must be the VA. X equals 0. And the last thing you got to figure out is the horizontal asymptotes. Is it bigger on bottom, bigger on top, same on both? It's just got X on top and X on the bottom. They're both power of 1. It is same on both. So then you kick into the ratio of the lead coefficients deal. Did you get 3 over 2? Awesome. That's how you do them, ladies and gentlemen. So I'll be over there. I'm going to turn on some music to cover up any conversations I have in this very quiet classroom otherwise. And I'm going to hope you'll walk up and ask me questions. On the graphing ones at the end, just look for it to be something like this. I totally understand you want to get started on your homework. Just look for 1 minute. Look up, please. Look up at the board. Do you see this? Look up at the board. Do you see this? Do you get that those x plus 1s would cancel? So if you had to graph this, it's really x squared minus 9. Isn't that like a parabola that's shifted down 9? Yeah, it's just got a hole in it. So really you're just graphing what's left here. You're graphing this. You've graphed those a million times. Parabola shifted down 9 looks like this. Except it's got a hole at -1. So you go to -1 and you drop down and you punch a hole in your graph. Doop. And you make sure it's empty. Like that. That's all it is graphing like you did before, but put the hole in at the end. So there's a few of those on today's, and that's a lot of what we do tomorrow. So I wanted to touch that just one last time. Thank you for looking up. That's all I got for you for today.